Okay. I hope all of us received the seminar materials, which were major questions. And I've requested one of you to volunteer and pray for us before we begin. So we can get a volunteer to pray for us, and then we begin our seminar.
Almighty Father, the Son of the pray. Almighty Father, I thank you for our lives. Thank you for the gift of everything you have given us, Jesus Christ. Pray that, Lord Father, we may pick everything that I want to learn from this seminar, so that it may help us in the future, so that it can help us in our month's life. In Jesus' mighty name I've prayed.
Amen. So could anyone be willing to discuss for us any number that they have prepared? And then we see what we can do with other numbers. So if you are ready with any number, you can put up your hand, and then I will call on you to present.
Okay.
So we have none that is prepared for the discussion to give us maybe a number or two. So if that's so, then let me.
What do you necessarily do?
First to start recording the.
So, welcome to this online lesson. My name is teacher Ashaba Frederick, and below there is my contact. So today we are going to focus majorly on trigonometry, and that is one of the topics which are under pure mathematics, and it majorly falls in Backhouse 1 and the other related books. So if I may ask, what is trigonometry before we go to our questions? What do we understand by the word trigonometry? You can put up your hand and then give us a definition, or what you understand by the word trigonometry.
Teacher, trigonometry bases on division and bases on geometry, division and partition. Yeah. And partition, yes, that's what that they can say.
Okay, thank you for trying. Any other to give us what they understand by the word trigonometry? So majorly with trigonometry, we look at the relationship between the three sides of a triangle and then the three angles. And we majorly focus our relationships on a right-angled triangle. So in a right-angled triangle is where we have any one of the angles being 90 degrees. So once n of the angles in a triangle is 90 degrees, then that is regarded as a right-angled triangle. And within that triangle, we have the sides. So each side has its own name. So I'm going to briefly illustrate them, and then before we go to our questions here. So we have a comment in the chat. Tony says the branch of mathematics dealing with the relations of the sides and angles of a triangle and with relevant functions of any angles. That is great. Thank you. So we said trigonometry looks at the relationship between the sides and three angles of a triangle. So I'm going to briefly draw some triangle here, and then we name the sides. So assuming that is our 90 degrees, then we have our major angle here that we can call theta. So name the sides marked A, B, and C. So how do we call side A? How do we call side B? And how do we call side C? So we could type our answers in the chat, or we can raise our hands up. So how do we call side A? How do we call side B? And how do we call side C? Yes, Benjamin, unmute and speak.
Side A
Yes.
is adjacent.
Adjacent.
Then side B is opposite. And side C is hypotenuse.
Okay, thank you. Thank you very much. We have as well as answers in the chat. B is opposite, C is hypotenuse. So thank you. Keep those answers coming in. Okay, so that is it. So this relationship here between these sides and the angles, so the angles as well 3. So depending on the position of the angle, other than the 90 degrees, that defines what should be the opposite and what should be the adjacent. So for example, if we consider angle alpha, now it changes. So the A now becomes the opposite side, and then B becomes the adjacent. Those who cannot hear, please check your audio connections and maybe you'll be able to hear. So that is briefly what we can say about the introduction to trigonometry. So what are the three trigonometrical ratios? The three major trigonometrical ratios? We can still put up our hands or type the answers in the chat. The three ratios that we use.
Sine, tan, and cos.
So we have sine, tan, and cos. Okay, sine, tan, and cos from key. Okay, so we have tan. Okay, so in full we call it tangent. So this is tangent. Then we have cosine, and this is abbreviated as cos. Then we have sine, which is abbreviated as sine that. So apart from these three major ones, what else do we see in A level? So what else do we have? Do we use only the three, the tan, cos, and sine? For some of us who have, yes.
We see the the constant, the secant, and the
Or tangent. Yes, we have Lillian says cosec. Jonathan says cosec. Jonathan as well says cot. So we have as well. So we have 1 over tan, which we define as cot. Then 1 over sine, and 1 over cos, which we define as sec. So from our, yes, the answers as well are coming in the chat. I can see them. So thank you very much. So from this triangle, let me first remove one of the angles. So what would be our, what would tan theta be equal to, cos theta be equal to? So what is cos? Let me see in the chat. So how would we define cos, tan, and okay, thank you. Let me choose another color that I can use. So from this triangle, what is tan of theta? What is cos theta? And then what is sine theta? Yes, I have an answer in the chat from Senyondo. Says cos is equal to adjacent over hypotenuse. So that is great. So cos, this one we define as adjacent divided by hypotenuse. So do I have some people with hands up to define for us?
Yeah, tan will be opposite out of adjacent.
So tan is opposite out of adjacent. Thank you. Faith.
Sine is opposite over hypotenuse.
Opposite over hypotenuse. So apart from saying tan is equal to adjacent over opposite over adjacent, how else could we express the tan? Okay, the answers in the chat. So how else could we express, yes, Jerusa?
Tan is sine out of cos.
Tan is sine out of cos. Thank you, Faith.
Tan can also be sec out of cosec.
And B?
Sec out of cosec.
And can be sec out of cosec. Okay, thank you. That one is also interesting. Okay. So that is a brief introduction about trigonometry, and we are going to build on that to see what can be done more in addition to knowing that sine and cos is equal to that. So let us go to trigonometry and Pythagoras theorem. So who can state for us Pythagoras theorem? How does Pythagoras theorem state? Yes, K.
S squared plus B squared equals to C squared.
That S squared plus B squared is equal to C squared. That is great. That if we have a right angled triangle, A squared plus B squared is equal to C squared. So what is A, B, and C? What is A, B, and C?
Opposite and adjacent.
Opposite and adjacent. Okay, thank you.
Teacher plus
So,
hypotenuse.
Plus hypotenuse. So in brief, the A and B are the short sides of a triangle, what we can call the adjacent and the hypotenuse. No, the adjacent and the opposite, then B is the hypotenuse. So when we get A squared, when we get the short side is squared, they give us the longest side. So let us try to. So in trigonometry and Pythagoras theorem, we have three identities. So who can tell us those identities, the three identities? Others may type in the chat. I guess there are some of us who have already studied trigonometry. So we have come across those three identities. Okay. Sine,
Teacher, it is
cos,
sine
tan.
squared theta plus cos squared theta is equals to 1.
So sine squared theta plus cos squared theta is equal to 1. So that is one of them. Thank you. Faith?
1 plus tan squared theta equals to sec squared theta.
Equal to sec squared theta. Thank you. Benjamin?
1 plus cot squared theta is equal to cosec squared theta.
Sec squared theta. So thank you very much. I have as well, there's somebody saying he has a low volume. So my volume is low?
No, not your volume.
Okay. So knowing these identities, so we can now begin from there and we solve our part of our questions that we have. So our first question for this seminar is sort of the following equations giving the values of theta from 0 to 360 inclusive. So our first part A, we have 3 minus 3 cos theta is equal to 2 sine squared theta. So how are we going to go about this? Yes, Ronald.
We are going to substitute sine squared theta with the identity, which is 2 into 1 minus cos squared theta.
Okay, thank you very much. So we are going to substitute the sine squared with the identity. So we get cos squared, sine squared is equal to 1. And then we make the sine squared the subject of the formula. So we shall say this would be 3 minus 3 cos theta, giving us 2 into 1 minus cos squared what? Cos squared theta. Are all of us able to see my screen? There's somebody saying he can't see my screen.
Yeah, we can see.
So here we are going to open brackets. On the right hand side, so this would be 3 minus 3 cos theta, giving us 2 minus 2 sine squared theta. No, cos. Sorry about that.
Technical problem.
Of course, squared theta. So what are we going to have as our next step? You can put up your hand. Yes, Ronald.
We are going to take 2 cos squared theta to the other side, to the left, and it becomes positive, so that we may form a quadratic equation.
So when it goes there, it becomes positive. So we as well take the 2. So when the 2 goes, it will also be negative, and this is equated to 0. So this would be 2 cos squared theta minus 3 cos theta plus 1 is equal to 0. So what do we do next? what would be our next step?
Teacher, I think we factor out cos.
We factor out a cos. Okay, thank you. Any other suggestion?
Teacher, we make this this bulldozer.
Use bulldozer.
No, teacher, teacher, these two here. Teacher, these two here will have to be divided.
I think it is a quadratic equation.
Yes, it
teacher,
is.
the two here.
It is a quadratic equation.
Teacher, these two here. The two.
Now, can we first put up our hands if we are to speak? So the two I think has no challenge.
Right, we just
yes. Faith.
Yes, Faith. We can if we don't pull out the cos squared, we can let the cos to be any unknown, and then we solve it in quadratic form.
Okay, thank you. Great. Jerusha.
Let cos theta be a.
Yes. Thank you. Ambrose.
Yeah, like for me, I'm seeing this one quadratic equation now.
Okay, so it is a quadratic equation. Thank you.
Yeah.
So here, most of us are suggesting that we let cos theta to be equal to A. Can I request that we mute our microphones? Such that this becomes 2A squared minus 3A plus 1 equaling to 0. Such that now that is a quadratic equation, then we can solve. So we can solve that to get the values of A. So can we find out whether it is possible for us to use factorization? Is it possible for us to use factorization? So when we get two numbers that we add, so we are going to get two numbers that we multiply to give us 2, and when we add them, they give us -3. So what could be those two numbers? Numbers that we add to give us, numbers that we multiply to give us 2, and when added, they give us -2 and -1.
-2 and
-1. Most of us are suggesting that we use bulldozer. It is somehow. So we are going to substitute those. So here we shall have -1 and -2. So when we multiply these two, they give us a 2. And when added, they give us -3. So we are going to substitute them such that we have 2A squared minus 2A minus A plus 1 is equal to 0. So after that, we are going to do the grouping. So we shall have 2A squared minus 2A in a group. Then we also have A. So since we are putting outside a negative, then we can change this one to a negative as well, such that it becomes A minus 1. Because after opening the brackets, we shall get negative times negative, which will again give us a +1. So we do that grouping. Yes, the calculator is okay, but sometimes in the exam they need to see the steps that you have listed down, because some of those steps are given method 1 and bonus, so we would need to do that. So what is the common factor in the first bracket and what is the common factor in the second bracket? We can put those answers in the chat, or one of us can speak.
The common factor in brackets 1 is 2a.
So we shall have 2a, and then we remain with a minus 1. Then in the second bracket?
In the second bracket, it is -1.
-1 into a minus 1, and this gives us a 0. So what would be our next step? What would be our next step? So we shall have, since a minus 1 is common throughout, so we are going to write it once. So we shall have 2a minus 1 into a minus 1. And this is equal to 0. 0. Yes. So what do we do after that?
We equate each
to find
to
the
0.
values of, we equate each to 0, so we shall say either 2a minus 1 is equal to 0 and our a is equal to 1/2. That is after taking them to the other side. Or we say a minus 1 is equal to 0 and a is equal to a 1. So are we done solving our equation?
Not yet.
Not yet. So remember, there is somewhere where we said our a, our cos theta was equal to a. So we are going to find, so when a is equal to 1/2, okay, our cos theta will be equal to 1/2. So what did we do to find the theta? What did we do to find the theta?
We take cos inverse of 1/2.
So we take the cos inverse of 1/2. So theta is equal to cos inverse of 1/2. And what is cos inverse of 1/2?
60 degrees.
60 degrees, thank you. So is it the only angle that we are going to have? Himbisibwe says we shall have another angle as 300. So our theta would be 60 and 300. So since the theta was positive, so here we look for angles. We look for angles in the quadrants, in our 4 quadrants where theta is positive. And that would be in the first quadrant and in the 4th quadrant. So can we get the values of theta when a is equal to 1? Just in 1 minute, we get the values of theta when a is 1. And we can type the answers in the chat and also speak them out here. So one had said the theta would be equal to 0. And 0 degrees and 360.
Only.
Benjamin also says 360. Blessing says 360. So finally, we shall write all these angles beginning from the smallest to the highest. So we shall begin with 0, 60 degrees, 300 degrees, and lastly 360. So Silas as well says 360. So that is great of us. Any questions before we move to our next number? Any question? Yes, Bonita. We can't hear you very well. Can you come again? You could type your answers in the chat, your question in the chat. It seems you have a poor network. Bright. Bright, we can't hear you as well. I can't hear you. You can as well type your question in the chat. Any other questions? Bonita and Bright, type your questions in the chat. So Bonita
Yes, my question
says
is,
what? Okay. So Bonita's question, what if I don't let cos to be A and I just solve it as cos? That would also work better as long as you deal with the cos consistently. It is okay. So if you can leave the cos in your working, it is also okay. So they don't penalize you for that. So it is okay to work with the cos. I think your question is answered. Then Bright, type your answer, your question in the chat. Then Kay, what is your question?
I don't know why there's something on the right side of my screen, like the names, they are covering the work. I don't know how to remove it.
The names.
Yes.
The names you. When there is an downward, I think like something, so you click on it and close it.
Okay, thank you.
Yes, welcome. So let us move on to our next question. So the cosec and the tan, this one is still done in the same way. So here you just use the formula that has here you substitute using 1 plus tan squared is equal to, I think this was supposed to be called, so you say a base way, because this is equal to sec squared, then we would solve that. I hope this was not a typing error, but it's supposed to be sec. So we also do that. So it is done in the same way. So here we have done one. So here you use the substitution 1 plus cot squared is equal to cosec squared. So we are not doing these numbers all because of time, but at least we have done the first one. So these two can be done in the same way, using either those who are comfortable with the bulldozer, you can use the bulldozer method, or you can use the factorization method, and then you'll be able to get the answers. Then Bright has a question. What of the solution to B quadratic equation obtained directly from the calculator without going through the method of solving? That one could be done, but you might end up losing a mark for not showing the working. So you will be at risk of losing 1 mark. So do these numbers since you have the questions after. Yes, Blessing.
Excuse me, teacher.
Yes.
Teacher, on part B, where it says cosec squared theta is equal to 3 tan theta minus 1. Teacher, is it a typing error?
Yes, it is a typing error. This was supposed to be sec squared.
Oh, okay. Thank you, teacher.
You're welcome. So it was supposed to be sec squared is equal to 3 tan theta minus 1. So then here we are going to use this substitution, and then we are going to substitute for cot, and then we'll be able to solve those numbers. There is, did I see a hand up? Benjamin, your hand is up.
I have a question. How are we going to get the angles of chords?
The angles of cot?
Yeah. Is it
remember we said, yes?
Is it that the answer that we are going to get is the only angle?
No, it can't be the only angle. For cot we said is 1/tan, isn't it so? So when you reach, maybe let's do this number, and then we see how we could do that. So, but here we are going to now use the calculator because of time. So this is going to be 2 into, so we substitute for cot. So cot is the cosec squared minus 1, isn't it so? Cosec squared theta minus 1, then plus 8 is equal to 7 cosec theta. So this is going to be 2 cosec squared theta minus 2 plus 8 is equal to 7 cosec. So here we bring the 7 to the left-hand side. So it becomes minus 7 cosec. Then plus 6 is equal to 0. So those who have calculators can substitute this equation for us in their calculators.
The answers are 2.
The answers, so we have cosec theta is equal to 2.
And then 3 out of 2.
And 3 out of 2. So what did we say cosec is?
1 out of sine.
1 out of sine. So we are going to say now 1 out of sine theta is equal to 2. So we put this 2 over 1, and then we cross multiply. So this would give us 1 is equal to 2 sine theta. Then our sine theta would be equal to a half. Then we take the sine inverse of a half. And then we get the values of what? Of theta. So what is the sine inverse of a half?
degrees.
30
degrees.
So 30 degrees. So what would be the other angle? Bonita says 30, 150 degrees. Okay. Yes, then we still do the same. We still do the same for when cosec is equal to 3 over 2. So we shall still have 1 over sine theta equaling to 3 over 2. And then we as well cross multiply. So we have 3 sine theta is equal to 2. And sine theta would be 2 over 3. And then theta would be sine inverse of 2 over 3. So we still get the values of what? Of theta. So what is sine inverse of 2 over 3?
41.8.
41.8. And then the other angle?
138.2.
130?
8.2.
0.2. So in this working, when you're working, then you find yourself having cosec. So you use this as 1 over sine, so that you're able to use the sine. Then sec will be 1 over cos, and then tan, okay, cot be 1 over tan. So you do that, and then you'll be in position to get the values of theta. I think I've answered the. Yes, please.
On the value of theta, when you use 2 as the value of cos, where did you get the second value of theta?
Cosec.
Yes. Where did you get the second? How do you get the second value?
That is a very good question. I think let me rub everything here. So this is how I get the second value. So we have our quadrants. So we divide the circle into 4 equal parts. And then we'll be able to name it. So this is known as the first quadrant. This is the second. This is the third. This is the fourth. So we begin from 0. Then we move anti-clockwise for positive angles. Then when we move clockwise, the angles are negative. So this would be 90. This would be 180. This would be 270. And when we get back here to make a complete turn is 360. So we have this abbreviation, which some of us say is acts, and then we come and write it. So in the first quadrant, all angles are positive. Then in the second quadrant, we have only sign being positive. So to answer your question, so we had sine theta was equal to a half. Then we could also have another situation where sine theta is equal to negative a half. So these two do not give us the same values. So when we calculate at first, for all of them, they are going to give us. So for the first one, we get the angles are going to lie in the quadrants where sine is positive. So can we have some of our microphones muted? So we are going to have to look for quadrants where sine is positive, which is the first quadrant, and the second quadrant. Then after taking the sine inverse, theta is going to be equal to 30 degrees, which is the angle in the first quadrant. So which would be around there. Then that is equal to still the angle in the third quadrant in the second. So how I get my 150 is that I need an angle from the positive x-axis up to that line. So this is a 30 and is the same as this other angle here, which is also what? 30. So to get the angle from the first, from the positive x-axis to this line here, I'm going to get 180, and then I subtract this 30. So when I do that, that will bring me to 150. So that is how we get our second what? Our second angle. So we move around this quadrant, and then we identify where sine is what? Is positive. So likewise for others, if we had cos, we would still look for where cos is what? Is positive. And we identify that. So in summary, in the second quadrant, we get 180 minus the theta. That is when if the angle lies in the second quadrant. Then in the third quadrant, this would be the angle. So in the third quadrant, we get 180. We add the theta. And in the fourth quadrant, so this would be the angle. And here this would be the angle. In the fourth quadrant, we get 360 minus the theta. So that is how we get the different angles in those different quadrants. I hope your question is answered.
Yes, sir. Thank you.
Okay, you're welcome. So let us proceed to our next question. So we are now going to some part of doing some proofs here. So who can help us to prove that very fast? By show of hand. You can put up the hand, then you speak as I write, or if you can manage to write, you can as well write. So that has no challenge. Yes, Brian. So what way can we write a tan? Which other way can we write a tan, and which way can we write a quote? Yes, Ambrose.
Yeah, tan is sine theta or cos theta.
So sine theta over cos theta. Then what is a quote, Faith? Then what is a quote, Faith?
Cos
Sine theta.
Cos theta divided by sine theta. So we have taken the left-hand side. So I would request that we mute our microphones. Yes, Ambrose. Ambrose.
I can finish now. To finish from that point.
Yes.
So from there we get the LCM now. The LCM.
The LCM. So what is our LCM?
Cos theta sin theta.
Cos theta sin theta. Then what do we do next?
When we divide with this first one, when we divide with sin theta or cos theta, we are going to get what? Sin square theta.
So here we shall get sine squared theta.
Then plus cos square theta.
Okay. Thank you.
Then I know that sin square theta plus cos square theta is 1. So cos square theta plus sin square theta is 1.
Yes. So we put, so that would be 1.
Out over cos theta sin theta.
This is equal to the right hand side. Okay. So that is done. Move to the next. Okay, there is a hand up. Faith.
Teacher, in the other number, we can also move from the right-hand side going backwards.
Okay. So we could do from the taking the right-hand side. So 1 over sine theta, cos theta.
Teacher, should I
Yes,
explain?
Faith, continue.
Should I
continue? Yes, yes.
You multiply that by a suitable one.
Yes, please come again.
You multiply the 1 out of sine theta cos theta by a suitable one, and that suitable one is sine squared theta plus cos squared theta.
Okay.
Yes, and then you separate the variables. You say cos squared theta out of sine theta cos theta plus sine squared theta out of sine theta cos theta. Then we can see that the cos squared theta reduces to cos theta out of sine theta. Then the other one reduces to sine theta out of cos theta. But we know that cos theta, sine theta is the same as cot. And sine theta, cos theta is the same as tan theta.
Okay, thank you very much. So we move to our second proof. Okay, K says, what is the difference between show and prove? So for prove, you can begin from any side. That is for prove. So for prove, you can begin from any side, but for show, you begin from the left and show that what is on the left is the same as what is on the right. That is the difference between show and prove. So for show, you must begin from the left-hand side and you show that it is equal to what is on the right. But for proof, you can begin from any side. I think that is it. Okay, Benjamin. So how do we go about this second one? You can put up your hand to guide us. So we are we have started our second hour and the last hour. So let us put in some extra speed such that we are able to finish up. Yes, Faith?
Teacher, let me start from left-hand side.
Left-hand side. Yes.
Sec squared theta minus cosec squared theta will be 1 plus tan squared theta into brackets minus 1 plus cot squared theta. Then you open the brackets. That will be 1 plus tan squared theta minus 1 minus cot squared theta. Then the one will cancel, the one will die. Then we have tan squared theta minus cot squared theta.
Okay, thank you very much. I guess we can move on. So we have the third one. So as we have moved into the last part of our seminar, can I request that we type in the chat our names, combination, and phone contacts, possibly the WhatsApp contacts. So we type our names, our combinations, and WhatsApp contacts. Thank you. So how are we dealing with this number?
Teacher, we start with the left hand side, and whereby the left hand side we look to this sec, the sec theta. A sec theta will be 1 over cos theta. 1 over cos theta. Then the tan theta will be of 1 sin theta over cos theta. Close brackets. Then open the other one. 1 over cos theta minus sin theta over cos theta. Then afterwards, if we multiply cos 1 over cos theta into 1 over cos theta, 1 over cos theta into minus sin theta over cos theta, you can proceed.
So that would be 1 minus 1 over cos squared. Okay, then
minus, this one is a minus, the next one, minus.
Pardon, what did you do there?
Minus sin squared theta, minus sin theta over cos squared theta, over cos squared theta. Then plus sin squared theta, plus sin theta is if this one comes here, sin theta over cos squared theta, squared theta minus sin squared theta, sin squared theta over cos squared theta. So we find the LCM on both sides. This the two, we combine the two, and then we find the LCM using cos squared theta.
I think this one and this one are going to cancel.
So then we remain with LCM, which is cos squared theta minus sin squared theta. So we continue sin squared theta. Then we throw it to the other side. The one will bring it to the other side. Then we bring it. If we bring this side,
Which one? So I think when we get here, we bring in the cos squared theta plus sin squared theta is equal to 1. So we have 1 minus cos squared. So we take this one the other side. So cos squared theta is the same as 1 minus sin squared theta. So we shall, where there is 1 minus sin squared, we substitute there the cos squared, such that we shall have cos squared divided by cos squared. And this would give us, which is the same as what is on the right hand side. Is that clear? Okay, thank you for those contacts. Let the contacts
So I didn't understand
come again.
The second and the third steps.
The second and the third.
Yeah, how did you
so
do
in
that?
this? So we are saying sec is 1 over cos. Then tan theta is sin theta over cos theta. So we closed that bracket. Then we went to the second bracket. We said sec theta is 1 over cos. Then tan is sin theta over cos theta. Then we got this first term here, 1 over cos, we multiplied by the second bracket. So 1 over cos times 1 over cos gave us 1 over cos squared. Then 1 over cos times sin theta over cos theta, it gave us sin theta divided by cos squared theta. Then we went to the second term in the first bracket, sine theta over cos theta. We multiplied it by 1 over cos, and it gave us sine theta over cos
Thank you,
squared
sir. I've
theta.
understood now.
Okay, thank you. Okay. Faith, give us your contact, please. We want everything, so give us the contact, the combination, and your name. Thank you. Okay, so we can leave this for the proofs now, and we go to our other section. So let us do some two numbers here still on the elimination. So we have x is equal to a cos theta, y is equal to b sin theta. So remember, we are still using cos squared theta plus sine squared theta.
Excuse me, teacher.
Is equal to 1. Yes, please.
Teacher, like about the previous number.
Yes.
Can I give an alternative?
Yeah, it is okay.
Simpler form. Yeah. Going back to the previous.
Let me rub this as well. Let me rub. Okay.
Yeah. Okay. Like I transform this. I am taking the left hand side. Then I turn second turn. In terms, I put second turn in terms of cos and sine.
Yes.
Then
so
after.
Like 1 over cos plus sine theta. Like that.
Yes, teacher.
Yes.
Then I get the numerators. I create brackets for them alone. Then I divide by the cos squared.
Divide by the cos. So you say 1 plus sine theta.
Yeah.
Divided by cos theta.
Yeah, cos squared.
Then 1 minus sine theta. Divided by cos theta. Okay.
Yeah.
Then you say this is 1 plus sine theta into 1 minus sine theta.
Yeah.
Over cos squared.
Over cos squared.
Okay.
Then the upper bracket is a difference of two. The numerator is a difference of 2 squares.
Yes. Okay.
Yeah.
Okay.
But remember, from the trig identity, 1 minus sine squared theta is cos squared.
Okay.
Then the answer is 1.
Thank you. So we had come to this. So I think majorly here, since we have sine and cos, we are going to use the first identity. So who can tell us what they had prepared for this number? Yes, Faith.
Teacher, you make in the first one, you make cos the subject.
So what will cos theta be equal to?
It will be x out of A.
Okay.
Then the other side, sin theta will be y out of B. But from cos square theta plus sin square theta equals to 1.
Yes.
We shall substitute in the values.
Then what? We substitute. So I think here we are supposed to first square. So we square this and then we square that. So that cos squared becomes x over A squared. Then sin squared becomes y over B squared. Such that this becomes 2 cos sin squared is equal to x squared over A squared. Then sin squared theta is y squared over B squared. Then from here, we substitute in the what? In the equation. Is that how you had it, Faith?
Yes, teacher.
Okay, so we transfer and substitute in the equation. So this would be x sin squared would be x squared over A squared plus sin squared, which is y squared over B squared is equal to 1. So do we stop there or we continue? Okay, then let's do this one and move on to our next number. So who can take us through this second part? By show of hand. Yes, Bonita.
We first solve, like we say x over A is equal to tan theta.
Continue.
And then the other side we say y over B is equal to cos theta. And then we say from tan theta, which is equal to sin theta over cos theta. It will be equal to sin theta.
Okay, sorry. Okay.
So we continue and say sin theta is equal to x over A, and then sin theta over y over B. Here where there is sin theta.
Come again. Yeah.
Sin theta over y over B. And
over
then
y over B.
Yeah, we cross multiply. Yeah. Then we use sin squared theta. Yeah, cross multiply.
X times Y
over then we shall use sine squared theta plus cos squared theta, which is equal to 1. Then we solve.
Okay. Any alternative method apart from this? Let me first finish up. Then here we use cos squared plus sine squared is equal to 1. So here we shall say xy over ab squared. No, that was for that. Okay. So xy, sorry about that. So we substitute in this. Let's see the different. Yes, Jerusha.
I was thinking, what if we just like, let me begin from this step where she already made like tan is equals to x over a. Then we get the identity, which is 1 plus tan squared is equals to sec squared.
Let me come. So x over a is tan
theta.
Yes.
Then cos theta equals to y out of b.
Cos
Theta.
y out of b.
Then we write in that identity, that is 1 plus tan squared theta is equals to sec squared. After that, we replace, we make tan squared, which will be x squared out of s squared.
Yes.
Then for cos squared, it will be y squared out of b squared.
Yes.
But remember, one out of cos is the same as sec. So sec squared will be b squared out of y squared.
Come again.
Sec squared will be b squared out of y squared.
Okay.
Then you replace in the identity, whereby we have 1 plus x squared out of s squared is equals to b squared out of y squared.
Thank you. Okay. So I think we are done with this. So for the rest of these ones, you do them in your free time. Because of time, we need to say at least what is in each part. So we can go to the formula for sine of a plus or minus b, and then cos of a plus or minus b. So who can tell us some of these formulas? What is sine of a plus b? Sine of a minus b, cos of a plus b.
So sine a plus b is equals to?
Yes.
Sine a sine b.
Sine a sine b. I don't think so.
Plus sine b.
This.
Plus cos b cos a.
I think that is for cos. For cos is where we have cos a, cos b. This would be sine a, sine b. Okay. Benjamin.
Sine a plus sine b is equal to sine a cos b.
Sin A cos B
plus cos A sin B.
Cos A sin B. Yes, thank you. Mojisha, Sarah.
Sin A minus sin B.
Yes.
So sin A cos B minus cos A sin B.
Okay. Okay.
Cos A minus B equals to cos A cos B plus sin A sin B.
Thank you. So now we are going to use these four identities, and we normally call them the compound angle formulas or formulae. So we are going to use them in this section here, where we are given that sin A is 4/5, and then cos B is 12/13, where A is obtuse and the B is acute. So we find the values of sin of A plus B. So how are we going to deal with that? Yes, there's some charts here. Okay, okay. So how are we dealing with this number here? By show of hand. Faith?
We shall first expand the sin A plus B.
Okay. And this
Sin A cos B plus cos A sin B. So we were given sin A and cos B, but we
yes.
don't have cos A and sin B. So we shall first get the values of cos A and sin B from the right angle triangle.
Yes. So which one is acute? B is acute. So we are beginning with, I think this is obtuse 180. So let us begin with that. So this is the angle A. This is 90. So sin of A is 4/5. So this is 4. And the hypotenuse is 5. So we are going to get the adjacent. So by Pythagoras theorem, what is adjacent of that triangle?
It will be
It would be
3.
3.
Yeah.
Okay. So this would be 3.
Yes.
So so that we are going to use this to get cos of what?
Cos of A.
Cos of A.
And cos is adjacent over hypotenuse, meaning it is 3 out of 5.
3 out of 5.
Then
Okay.
we also look for sin of B, sin of the angle B.
Sin of the angle B. So we can as well use this, we can draw another triangle. Cos of B, cos is adjacent over hypotenuse. So what would be the opposite side of B by use of Pythagoras theorem?
5.
5. So what would be cos of A?
We are looking for sine of B. Cos of
Sine of B.
yes.
Sine of B.
It will be opposite over hypotenuse, which is 5 out of 13.
13. Okay, then we now come and substitute in our formula.
Yes.
But remember they had said A is what?
Obtuse.
So in which quadrant is it?
It will be in the second quadrant.
In the second quadrant. And in the second quadrant, what is the sign of cos? Is it positive or negative?
It's negative.
Negative.
So we shall give 3 over 5 a what? A negative. Yes, so we come and substitute. So what is sign of A? Sign of A is 4 over 5.
4 over 5.
What is cos of B?
12 out of 13.
Then we add cos of A.
Negative 3 out of 5.
Sin B.
Five out of 13.
Then we multiply 4 times 12, and then 3 times 15. No, 5 times 13. This would be 15. What is 5 times 13?
65.
65.
Yes.
And what would be the final answer here? 33 over 65.
Yes.
Okay. There is a WhatsApp link that has been posted in the chat, so you could follow that link to join the group. Okay, so we have seen this number. So when you find numbers of this form, you need to first expand the expression, and then you substitute in for the values of the ratios given.
So I have a similar number. Can we do it?
Yes. You have a similar number?
You say the acute angles A and B are such that A is negative a half, cos A is negative a half, sin B is negative a third. Show without the use of tables and calculators that tan A plus B is equals to 9 root of 3 plus 8 root of 2 out of 5.
I suggest we do that at the end. We even have 20 minutes left.
Okay, sir.
Yes. So I think for numbers of this form, we are not going to do the rest. So we want to at least cover most of the of what we had planned. So at least we have seen what we can be able to do. Tumwes J is saying is it acute and the cos is negative? So an acute angle is the angle between 0 and 90. And we have seen that in that quadrant, all the ratios are what? Are positive. So when it is acute, the cos is positive because it is in the first what? In the first quadrant. So let us move on to our next. So these ones will be able to attempt them. Maybe we can do this proof here. Okay, let us do this tan. So they're saying if tan A plus B is 1/7 and tan of A is 3, find the values of tan of B. What is the expansion for tan of A plus B? Tan of A plus B? Yes.
It's tan A plus tan B out of 1 minus tan A times B.
So we are going to do the same here. They are saying tan of A is 3, and then tan of this is equal to 1/7. So we are going to say 1/7 is equal to tan of A, that is 3, plus tan B, that we are finding, divided by 1 minus tan A, which is 3, then times tan of B. So in here, we are going to cross multiply. We have 1 minus 3 tan of B is equal to 7 into 3 plus tan of B. So what did we get on the right hand side after opening the brackets?
21 plus 7 tan B.
And then what do we do next?
We collect like terms.
We collect like terms. That is good. So we are going to take, so 1 minus 21 is equal to 7 tan of B plus 3 tan of B. I hope I've done the right thing. This, the other side, this, yeah. So what is 1 minus 21?
Negative 20.
Negative 20 is equal to
10 tan B.
10 tan of B. So automatically here would divide.
Yes.
And tan of B would be equal to negative 2. Okay. Faith and Bonita, do you have any questions or your hands remained up?
No, sir.
Sorry.
Okay. Bonita, remove that mark there. Okay, to Benjamin, remove the arrows unless if you're asking something. So if you haven't typed your names, your combination and telephone contact in the chat, please do so.
Teacher, Maybe on my side, my introduction, I'm Musana Moses from Uganda. I just got the link on WhatsApp.
Okay, thank you for coming.
Yeah.
Maybe you could rename and then other participants get to know your name.
Okay.
Yes. So this one here, it is just a matter of expanding the two sides as we have seen, and then you'll be able to correct the terms in X. Then the proof of this, we expand both of them. So who can explain to us?
I think, teacher.
Yes.
We consider the right hand side. Then we expand sine into a plus b, which is sine a cosine b. Plus cosine a sine b. Then plus we again expand sine a minus b as sine a cosine b minus cosine a sine b. Then from our expansion we can see that we have cosine a sine b, and then minus cosine a sine b, we cancel them, remaining with sine a cosine b plus sine a cosine b. So we, in our equation we have sine a cosine b, and in that side we have sine a cosine b, which is 2 sine a cosine b, which is equals to the right hand side.
I think this one here was also a typing error. Okay, thank you. So that one is still done in the same way.
Yes.
Okay, so you expand the two, and then you'll come up with that. A proof of this. We have 13 minutes. So this we can say is sine A over cos A as sine B over cos B. So it is not so technical. You just do the LCM and the stuff, then you'll end up with this, what is on the left hand side.
Yes.
So that one is doable. So I think, can we proceed?
Yeah.
So I think we might end with this one. Prove that tan of A plus tan of B, okay, tan of A plus B plus C is equal to tan A plus tan B plus tan C minus tan of A tan of B tan of C divided by 1 minus tan A tan B minus tan A tan C minus tan B tan C. And hence, we prove that if A, B, and C are angles of a triangle, then tan of A plus tan of B plus tan of C is equal to tan A, tan B, tan C. So we can start. So we do this number together. So who can start by guiding us? So what we are going to start by doing is to expand. So we are going to begin from the from the left-hand side. So we shall have tan of A plus tan of B plus tan of C. Yes. So we are going to begin by saying this can be written as tan of A plus B and then plus C, such that inside we create two brackets. Is that okay?
Yes.
So inside we are going to create after expanding, so how shall we expand this? Tan of A plus B. So the A plus B is taken now as one term, and then plus C. Yes, Benjamin?
That will be
Yes.
tan A plus B.
Tan?
A plus B.
Yes.
Plus C. Plus tan C.
Plus tan C.
Out of
Yes.
1 minus tan A plus B. Tan C.
Yes.
Should I continue?
Yes, please.
So we shall first give shall first work out tan A plus B, which is tan A plus tan B. Out of 1 minus tan A tan B. And we put all of it in bracket. Plus tan C. Out of 1 minus tan A plus tan B over 1 minus tan A tan B
Yes, please.
I'll put that solution in brackets of tan A tan B and over 1 minus, yeah, that one.
Yes.
Then tan C. Hearing me?
Yes.
Will be open bracket.
So on this first one.
A.
Which type of soil allows a
Yes.
head of water to pass through it?
Tan C.
Long story.
Open bracket. 1 minus
Yes, teacher.
tan A.
Long story.
Close bracket. Then out of
Yes.
1 minus tan A tan B.
Okay.
it when it is in bracket out of 1 minus tan A tan A tan B minus
Come again.
Minus open bracket minus, say minus
Yeah.
open brackets
Now, here I suppose since we have this, we are supposed to multiply it here by 1, and then we put it over 1 minus tan A, tan B. I think that is what we are supposed to do there. Is it okay? So that we create an LCM stuff.
Look at you.
Yeah, since we put this over 1.
No problem.
Okay, we put that over 1, so that after multiplying, this becomes 1 into 1 minus tan A, tan B, then minus this times tan C. Yes. Then times still tan of C. This one is in bracket, divided by its LCM, which is 1 minus tan A, tan of B. Is it okay up to that point? Yes, okay.
Teacher, the upper part.
Yes.
On the second step, there is, on the denominator of the second step, there's a plus.
The denominator of the second step.
There's a plus instead of times.
Times C here.
No, this on 1 minus tan A plus B, tan C into tan C. There's a plus instead of times.
Where? I'm not saying it.
There where
here.
you are.
Here.
No, down.
Here.
Yes, there's a plus instead of times.
This is tan C. It is tan C. It is not a plus.
1 minus tan A plus B.
Yes.
Isn't it supposed to be multiplication?
Here,
yes.
Here, in brackets.
Yes.
No, it is a plus. Inside the brackets, it is a plus.
Okay.
Yes. Okay, so when we get to this step, well, what do we do next?
This one.
We have 2 minutes, please. Let's be faster.
Teacher, the denominators are the same, so we can cancel them out.
So this one and this one cancels out, okay?
Yeah.
So we are going to remain with the upper one, which is tan A plus tan B. Then here we open brackets, tan A times 1, tan C times 1 is tan C. Then tan C times tan A tan B is going to be tan of A, tan of B, tan of C. Then we divide everything by 1 minus tan A, tan B. Then minus the second bracket. Please, can we mute our microphones? Okay, that went down. Please, okay, we get in touch. So we shall get tan of A times C, which would be tan A, tan C, and then minus as well tan of B times C, which would be tan B tan of C. Are we there?
Yes, teacher.
Okay. So I think when we write this, it is what we are seeing here.
Yes, sir.
Yes. So now we can go to the hence part and then we conclude.
Yes, teacher.
So we have just proved this, so we can go to the hence part. So if A, B, and C are angles of a triangle, we prove that tan A plus tan B plus tan C is equal to that. So if so we are saying A plus B plus C, if it is the angles of a triangle, it will add up to 180. Then so that means we can have tan of 180 is equal to tan of A plus tan of B plus tan of C minus tan A, tan B, tan C. So we divide this by 1 minus tan A, tan B, tan A, tan C, and then tan B, tan C. So what is tan of 180 degrees?
Teacher, I haven't understood the second step.
Which second step?
Tan into 180 degrees is equal to tan A. And
so we are substituting in this. Remember, we have just proved that it is equal.
Yes.
Yes. So we are saying if they are angles of a triangle, so we know that all angles of a triangle add up to 180 degrees, isn't it so?
Yes, sir.
Yes.
So we are saying A plus B plus C is equal to 180.
Yes.
And then it is, we are equating it to what we have just proved.
Oh, okay. Okay.
Yes. Then what is tan of 180? I've seen in the chat they are saying it is 0. Okay. So this is 0. It is equal to the whole of this. Okay. So if we multiply, if we cross multiply, and this is equal to 0, the denominator will, after cross multiplying, it will disappear. Isn't it so?
Yes.
Yes. So that means our 0 is going to be equal to tan of A plus tan B plus tan C minus tan of A, tan of B, tan of C. And then we take one of them to the other side. So if this one goes this way, we shall have that tan A plus tan B plus tan of C is equal to tan A, tan B, tan of C. And we would have ended with our what? Our proof. Any questions? Okay, do you have a question? So if there are no questions, let me
Teacher, thank you so much.
you're welcome. There is some little communication that is coming up.
Excuse me, Teacher Shaba.
Yes, please.
Are you done?
Yes, because of time.
Okay.
Yes.
Oh, yeah. I can see.
Yes.
All right. Now,
okay.
This goes to everyone. Please would like to take a few minutes, check in your chat, check in the chat and fill in that form. It will help guide us do better next time. So I'm putting it in the chat now. Just take a few minutes and fill it. Hope you've seen it. Please take a minute and fill it. Otherwise, thank you for attending. Back to you, Teacher.
Okay. Can I request one of the maybe Mr. Kakuru to say something since I've been talking from the beginning. So can we have someone from the head team to say something? Okay.
Well, Teacher Kakuru has gone for a meeting.
Okay.
I can say a few things. This is actually, thank you everyone for attending. We should be having this seminars every week. We have seminars of lower primary, that is from P1 to P3, then upper primary from P4 to P7, lower secondary, that is O level, and upper secondary, that is A level. So these seminars will be happening every Friday of every week. And we shall be holding two seminars, one in the morning, and that is for primary, and one in the afternoon, that is for secondary. So make sure that you tell a friend to tell a friend. We encourage and welcome more people. You tell your brothers who are in lower secondary, tell your sisters, tell your neighbors to attend these seminars. These are helping us, and we know, we at Yaka know that we're in difficult times, so we are looking for how to rejuvenate our brains. And, you know, some people have started, some students have started being rusty, but we are keeping up with these seminars so that we can wake our brains up. When the schools open up, hopefully we shall be there. Now, in front of us, we have a graphic. We have online classes, so you're encouraged to subscribe. Most of us here are not subscribed to the platform. Some are. So we have classes and live teacher engagements like Teacher has been doing. And payment is 100,000 monthly, 500,000 per year per student. This includes unlimited access to educational content, that is the Ugandan curriculum, and live teacher engagement. When you subscribe, you're free to call Teacher Shaba at any time of the day to help you with your work. Okay. So we also have Educare. This is self-paced reading. This when you sign up on Educare, you don't have teacher engagement. You only have access to reading material only. Okay. So we encourage everyone to sign up on Yaka, and we keep schools, the school setup running. Thank you for attending. Thank you, Teacher Shaba, for taking us through that lesson. We already have one. We have one comment from a headmaster who has appreciated you and would like to get in touch with you. We will discuss the details with Teacher Kakuru. Is that okay, Teacher Shaba?
It is very okay.
Okay. All right.
Yes.
Thank you for the lesson.
All right. For us here at Yaka, we say bye. Thank you. And you look out for another seminar coming up.
Okay, thank you, teacher.
You're welcome.
All right. Thank you so much. Again.